We will be studying about the simple harmonic motion. What is a simple harmonic motion? We know that it is a special kind of periodic motion wherein the force is directly proportional to the displacement produced on application of the external force. So let us consider a system, a spring mass system, in this particular manner. The mass is m and the original distance is x0 with respect to the origin. Once some external force is applied to stretch the spring, so we can see that external force applied can be F dash, and then restoring force will be acting on the opposite side to bring the spring mass system into its original position. Okay, and let us suppose original length was x0 and we have produced x amount of more stretch after applying the force F dash, and then we can consider this whole length as x dash. So this is the diagram that we will be considering while solving the simple harmonic motion wave equation. Okay. So as per the simple harmonic motion, we know that we will be applying the equation of motion as per the Newton's law, second law. So while writing the equation of motion, we can say that when force F is being applied from outside, so we will say force F dash is actually equal to mass into acceleration. Then equal and opposite force is being applied, or restoring force acts on this particular system, which is actually equal to minus kx, where k is the restoring force constant. Okay. On equating, because these are acting in opposite directions, so we can equate the two equation ma is equal to minus kx. But further we know that acceleration is a double derivative of the displacement produced. So we can simply write it as m times d2x upon dt square is equal to minus kx. So we have reached onto the equation of motion in this particular format. Okay. Someone is trying to join the panel, just hold on class. So we have reached onto this particular equation of motion, which says that m d2 by d2x by dt square is equal to minus kx. This is equation number 1. So we can also represent it in the format like we can bring the m on this right hand side, and our equation will reduce to d2x upon dt square plus k upon m times x is equal to 0. But k upon m can be represented in terms of omega. What is the relation? Omega square is equal to, yes class?
Under root k by m.
Yeah, k upon m. Already I have taken omega square here, so I can write it as k by m. Or omega is equal to under root k by m. That's perfectly fine. So this equation will turn out to be d2x by dt square plus omega square x is equal to 0. Now we will be applying the differential equation. Has differential equation been studied by you all in the maths class? Differential equation. How to solve a differential equation? Yeah, we take d2 by dt square as d square, and we take d by dt as d here. Okay, so we have a double derivative of x term, which is a displacement term, so I can represent it in the format d square x plus omega square x is equal to 0. So what can I do? I can take x common here, so it will be written as g square plus omega square times of x is equal to 0. So simply x cannot be equal to 0 because obviously displacement is 0. This whole equation will become not invalid. Okay, so we can take this particular coefficient d square plus omega square equal to 0. So I can find out the root in this format. D square plus omega square is equal to 0. And finding out the root, d will be equal to how much value? Plus minus iota omega. What is iota here?
Root minus 1.
Yes, under root minus 1. This is an imaginary one. Why? Because d square was coming out to be equal to minus omega square. And if we take the value of d square, If we take the under root of minus term, obviously we have to consider the imaginary part, because under root of a negative term cannot be taken. So, but we know that minus under root 1 is equal to iota. So, we can write it as plus minus iota omega here. Okay. So, roots are here. Roots of equations are plus minus iota omega. Now, class, please tell me, depending on the roots, like we can say roots are equal in magnitude. First of all, these are imaginary roots. These are imaginary roots which are equal in magnitude but opposite in sign. Sign is different. So how will we write the complement equation for this using the differential part? We have a format x is equal to c1 e to the power alpha 1 x plus alpha 1 t plus c2 e to the power alpha 2 times of t, right? Alpha 1 and alpha 2 are roots of the equation. Like there are two roots, imaginary roots, equal in magnitude, opposite in signs. So we can say we will just put the values of these roots here in this particular equation. So in your differential equation chapter, you all must have studied that depending on the roots, you decide the complementary equation. There is a table, there must be a table in your books that depending on the root, whether you are getting real roots, then what kind of equation you get, and depending on imaginary roots, if they are equal in magnitude or they are opposite to each other, then how to write the differential equation, right? This is how we write the complement equation, where C1 and C2 are. Have you studied this part, class?
Cadets.
Yes. Okay. Constants of integration. So today you have read this part, right?
Yes, ma'am.
Okay. So this is how you get the complement equation. Okay. Simply you can decide depending on the roots you get the equation. Okay. So we have got this particular equation. So we can put the values and our equation will turn out to be x is equal to c1 e to the power बोलो बच्चों iota omega t
Omega
plus c2 e to the power
minus iota omega.
very good minus iota omega t. We can label this equation as equation number 1 was there, 2 can be our roots, and third is this equation. Okay. So, and we know from the Euler's theorem in math. What does the Euler theorem state? It states that e to the power iota theta is equal to cos theta plus iota sin theta. So we can represent in terms of cos and sin now. Okay. So on writing in terms of cos and sin, our term will change to cos omega t plus iota sin omega t plus c2 cos omega t minus iota sin omega t in this format. Now what we can do, we can take the cos common and other part we can take it as the sin term as a common here. So on taking these terms common out, we will get our constant in the bracket, which will be equal to c1 plus c2 cos omega t plus iota c1 minus c2 sin omega t, right? Now let us take this. This is a sum of two constant of integration. So this can be equal to a new constant a, and obviously we can take this as a other constant b because it's an imaginary term, distance term, and it's an addition term. So we have assumed let c1 plus c2 is equal to a, and let b term is equal to iota c1 minus c2. Okay. So simply let's represent it in further format. It will be equal to a cos omega t plus b sin omega t. This is equation number 4 that we have got. Okay. Now we can further simplify this equation by taking a and b where we will take it as, let A is equal to r sine theta and B is equal to r cos theta, just to simplify the terms, where r is actually giving you resultant amplitude of this simple harmonic motion. Okay, resultant amplitude is r, and theta is the phase with which the vibrations have been created. Okay, so x is equal to, r can be taken out simply, sine theta cos omega t plus cos theta sin omega t. Now sin A cos B, sin B cos A, it can be written as r sin A plus B omega t plus theta. Again we have reached to this particular equation. Okay, this is the equation for the simple harmonic motion. You can say general solution for simple harmonic motion, SHM. Okay, but now we are considerate about this particular x value. X value क्या थी हमारी? It was the displacement which was produced on application of some external force. As external, what was the stretch which was produced in the spring mass system? So we are considerate about this particular x value. X is equal to r sin omega t plus theta, where r is equal to, what is the value of r, class? Under root a square plus b square. Is it clear what we are doing? And
Yes,
theta
ma'am.
will be equal to tan inverse
B by
b by tan inverse a by b or b by a, class? Once you divide these values, if I take it as a part, is the b part, r sin theta is equal to a upon r cos theta equal to b. So it will be
yes,
tan
ma'am. A
inverse
by B.
a by b. Yes. Okay. So these are the values of the constant which are there, which we take in the previous equations. Okay, so we have to keep it here. After getting the equation, we have to say that where r is having this value and theta is having this value, we have to mention this thing. Okay, now let us proceed further. We have got the equation. So if, what if I want to calculate the maximum value of amplitude value, what will be the value of x max? x मैक्सिमम वैल्यू क्या आएगी इसकी, बताओ बच्चों? x मैक्स कितना आएगा?
हमारा आएगा
r, yes. x max is equal to r,
R.
which is further equal to under root a square
A square
plus
plus B
b
square.
square. Okay, so this is the maximum value of, you can say, displacement, and r is the amplitude. So displacement is actually equal to the amplitude. So we can draw, if we are drawing this graph, so we will say that maximum value of x, it is actually equal to r only. Okay, like this. So it will be starting from r itself. It's a sine or cos depending on the phase. We can draw it from 0 or 1, any case. Okay. So now next thing that we have to calculate is, that is velocity and acceleration. So displacement is here. And next thing, how to calculate velocity and acceleration now? Anyone who can tell this thing?
डिफरेंशिएट कर
Yes,
देंगे x
very good. We will differentiate once to get the value of velocity and differentiate twice to get the value of acceleration. As simple as that. So on differentiating, let us see our value of, now next task is to calculate the velocity and acceleration. The velocity will be given by dx upon dt. Now we are having the value of x d upon dt of capital R sine omega t plus theta, right? Now what you will do, R is a constant under root a plus b square, so differentiation of sine is the cos term, but yes, there is a constant omega, omega will come outside and then cos omega t plus theta, right? So we have got the velocity value equal to R omega cos omega t plus theta, right?
Yes, ma'am.
Okay, so let us mark it as equation number 6 here. Now for having the maximum value of velocity, obviously this cos term, cos value varies from -1 to +1, so we can take it as +1 value. Okay, and so we can say that from here we get to know the maximum value of velocity is actually equal to R times omega. That is a 7. Okay, and then so you can see here, class, we are getting a sine term for displacement, we are getting a cos term for the velocity. So when we will draw the graph, this can be the, okay, r omega will be the amplitude of velocity. If you are plotting the velocity, and if you plot the displacement on this vertical axis, the time is here, and again you are plotting it here. So it is a sine term. So it will start from here, and another thing will be maximum amplitude is r here. Getting the point? How do you draw this graph with respect to displacement, velocity, and then comes the acceleration part? We will derivate this equation again to get the acceleration value, because acceleration is dv upon dt. Again your graph will be a sinusoidal curve. Getting my point? And it will be having some amplitude which is coming in the coefficient. Okay? So let us see the acceleration part now. Is it getting clear?
मैम
हाँ जी.
मैम आपकी वॉइस में थोड़ा डिस्टरबेंस आ रहा है.
Is my voice clear now? Is my voice clear now? Class,
Yes,
anyone?
ma'am, clear to me.
Anyone who is able to listen clearly?
No, ma'am.
No, it is not clear. Okay.
It's clear with me.
जिनको clearly आ रही, please can you rejoin, because it is बाकियों को clear आ रही है, बच्चों एक बार
Now, now it's clear, ma'am.
okay, thank you so much. Okay, so now we have to okay, yeah, you can just notify me when it's not clear. Okay, acceleration is equal to dv upon dt. So what will be the value of acceleration, class? Can anyone tell me this thing? D upon
minus omega square r sin omega t plus
perfect, right answer, very good. So it will be cos omega t plus theta here, and as told by one of the students, minus omega square r sine omega t plus theta. So I can further write it in terms of displacement, right? Can I further write in terms of displacement now?
Yes, ma'am.
How? Tell me.
Minus omega square.
Minus omega square times of x, because r sine omega t plus theta, we already saw that it is equal to the x value. So we can put this value 5 in this equation. So I will mention here using fifth equation. Okay, so it will be equal to minus omega square x. This is your equation number 8. Okay, equation number 8. So we have got this value also. This is how we calculate the displacement, velocity, and acceleration for the SHM, simple harmonic motion. Okay, so depending on the angle or phase with which it is traveling, we can plot various graphs for displacement, velocity, and acceleration. Okay, now next thing that we have to see is calculation of kinetic energy, potential energy, and total energy for the SHM. So let us calculate the energies. kinetic energy.
हमें तो ये सिर्फ फॉर्मूले याद रखना है ना.
No. You need to learn these derivations also. Even you have done in 11th class, I know that, but you have to know about these derivations also. Okay.
Okay, ma'am.
Yes. And I will be making you to solve certain numericals today, so don't worry. You will get to know how numericals are based on the superposition theorem, on the simple harmonic motion, and so on. Okay. Both numericals and
Okay, ma'am.
derivations need to be done by you. So let us assume kinetic energy is represented by K symbol here. You have, I think, already done in 11th class also, right?
Yes, ma'am.
Yes, it's not a problem. It is there in the syllabus. Okay. So kinetic energy is equal to half mv square. So can anyone quickly tell me the value of kinetic energy? Like V value, we will take from equation number. What is the value of V? Equation number, this you can say 7th equation. Okay. R omega cos omega t plus theta. So I will put the value V is equal to R omega cos omega t plus theta. Once you put the value, it will be half mv square. So R omega cos omega t plus theta whole square. R square omega square m comes out, and cos square can be written as 1 minus sine square. So let us write in the format 1 minus sine square omega t plus theta. Okay. Now let us shift to next page. So kinetic energy is equal to m omega square upon 2. Now what I am going to do in this particular step is I will take this r square term inside the bracket. So what will happen? It will become r square minus r square sine square omega t plus theta close bracket, or simply n omega square upon 2. So again this can be written as
X square.
yeah. So this is the value of kinetic energy that we have got. Your equation number 9, m omega square upon 2 r square minus x square. Now to see how kinetic energy is varying, we will take two positions. We can take one position, mean position, x is equal to 0. That will be its mean position, original one. And maximum amplitude, x is equal to plus r or minus r. That is the extreme position, right? So what will be the value of kinetic energy at mean position? Tell me, class.
Omega square r square by 2.
M omega square, very good, r square upon 2. So this is the K max value. And kinetic energy is observed to be maximum at the mean position. And if we talk about the extreme position, it will be equal to
0.
yeah. So for simple harmonic motion, kinetic energy is maximum at mean position and minimum at the extreme position. This is how we have find out the value of kinetic energy. Now we will be finding out the value of potential energy. Okay. Now we know that small amount of work is done by applying the force F dash. We have applied the external F dash force to extend the spring, okay, by small distance dx. So we can write it as work done is equal to F dash times dx, and it is done in the same direction, displacement in the same direction as the force applied, so cos 0 degree. Okay, and we know that F dash is actually equal to minus F, which is equal to the restoring force. So we have said that external force applied is equal to negative of force, restoring force. So our equation are reduced to minus F dx. Now F is equal to minus kx. So minus kx, it will cancel out. So we will get kx dx is equal to dw. Now simply potential energy is equal to work done to produce the extension x in the system. So 0 to x, because we are producing an extension x and integrating on the both the sides. On integrating, we get work done is equal to half kx square, right? This is already in terms of x, displacement, which we were trying to find out earlier in terms of displacement x. So it is already, we have got the answer in terms of x, okay? Now we can represent this k in terms of m and omega. K is actually equal to m omega square. So let's put it so that we can have all, because kinetic energy we also took in m omega square. So let us convert this potential energy also in m omega square terms. So it can be simply written as potential energy U is equal to हाफ के एक्स स्क्वायर, और के का वैल्यू पुट करने पे क्या होगा, हाफ एम ओमेगा स्क्वायर एक्स स्क्वायर. Now class, tell me how the potential energy is going to behave at mean position and extreme position. Mean means x equal to 0. So it will be equal to x0, so u is equal to 0. This means minimum value of potential energy is observed at the mean position, because kinetic energy was maximum at the mean position. But if we take the extreme positions on both the sides, what will happen, class? We will get the maximum value, right? And same, which kinetic energy was getting the same value. Okay, the same value of potential energy, it is the maximum at the extreme positions. So at mean position, kinetic energy is maximum, and at extreme position, potential energy is maximum. Now, the third step is to find out the, so I can label it as equation number 11 here. I'm sorry, 11 here. So, here, okay. So now our next task is to find out the value of total energy, right? How to get the total energy. Total energy can be written as, tell me class, sum of
kinetic and potential of kinetic.
yes. So it will be equal to half m omega square r square minus x square plus half m omega square x square. This term will get cancelled out with this term. One is negative, one is positive, so we are left with the constant values, half m omega square r square. This is total energy. Total energy is constant. It is independent of the displacement produced. Okay. So this is equation number 12. Now we have got the equations for kinetic energy, potential energy, and total energy. Now our next task is to plot the graph between all three energies with respect to displacement x. Okay, let us start with the plotting of graph. Simply what we will do, so let us take displacement on x-axis. Okay, this is origin. Okay, so I can see that our it is having a the variation of okay, we have to see three energies. Energy can be taken on the y-axis, displacement on x-axis. First of all, total energy is independent of x. I am getting a constant value of total energy, half m omega square r square. I will mark this point is equal to half m omega square r square. This is the curve for total energy, I can say. Okay. Then I want to draw the kinetic energy. Okay. So I got to see that kinetic energy was 0. What was maximum? It was maximum at x equal to 0. यहाँ एक 0 है, maximum था. And if we talk about x equal to plus r and minus r, if I take it as x equal to minus r, this is x equal to plus r. So it was minimum at these 2 points, and I can say that half m omega square r square was the curve. So it's a parabolic curve, so I can draw it in this particular format by joining the points and tracing the equation which is there. By keeping different points, I get this kind of curve. This is a curve for kinetic energy, which is equal to, kinetic energy was equal to half m omega square r square minus x square. So depending on the variation of x values, I can plot this curve. Okay, and if I talk about the curve, that is a potential energy curve. So as you can see here, potential energy is minimum at x equal to 0. So I will mark x equal to 0 point first, minimum at x equal to 0. It was maximum at the x equal to plus r and x equal to yeah minus r. Okay, again we have got this kind of curve here. It's a smooth curve actually. Okay, so again this is ready. Okay, now I can see some points which are intersecting, or at what is happening actually these points. Kinetic energy is actually equal to potential energy because they're intersecting at these points. So what are the values of these points? Can anyone tell me how to find the values of these points? So what I will do, I will just equate the kinetic energy with potential energy to get the values. So I can do half m omega square r square minus half m omega square x square is equal to half m kinetic energy is equal to potential energy here omega square x square. So how do you find the value? Do you equate the two equations? Simply half m omega square can be taken out and cut in all the things. Okay, so you will get r square minus x square is equal to x square. Once x square goes on this side, what will happen? It will become a positive. Okay, so it will be r square will be equal to 2x square, or x can be written as r under root, because x square can be written as r square upon 2, or from here we can get x is equal to plus minus r by root 2. From here we can get x is equal to plus minus r by root 2. So this value will be minus r by root 2 and this value will be plus r by root 2. This is how we have got the point at which both potential and kinetic energy will be equal. Is it clear, class?
Yes, ma'am.
Okay. Is there anything you want to ask? Okay, so we are starting. So SHM is till this point only. Simple harmonic motion, calculation of displacement, velocity, acceleration, and energies. Okay.